Today we are going to cover Objective 13. We are going to learn how to perform operations with imaginary numbers. So before we can go into quadratics, we've got to learn how to work with imaginary numbers because some of your answers when you solve a quadratic are imaginary. So you got to understand once we solve those what you're dealing with. So we're going to kind of take a little break and solve imaginary numbers. So this is the definition of imaginary number. An imaginary number is defined as I squared equals -1 or the square root of -1 is equal to I. So basically, if you take the square root of -1, we already know that we talked about earlier this year that you cannot take the square root of a negative because in order to get a square, you times something by itself, like a positive times a positive would be a positive, or a negative times a negative would be a positive. There's not anything times itself that equals a negative. So what we do with it so that we can continue on with our problem is we take the 1 out. So the square root of 1 is 1. And then we take the negative out, and the negative comes out as an I. And what is 1 times I? I. So that's where they get that the definition is the square root of -1 becomes an I. You just make it a variable, an I, so that you can continue on with your problem and keep working with your problem. Okay? And then likewise, if you put it back in, if I squared I and put it back into the radical, it would become -1. So we know that I squared is equal to -1. And whether you follow with me or not follow with me, here's what I will say. Memorize that. That is the definition. Memorize it. Okay? And then the second definition is a complex number. So when you have a real number and an imaginary number, you generally write it in the form a plus bi. So if I have the number 3 and then I have a 4i, you say 3 plus 4i versus 4i plus 3. You always put the real number in front. That's just proper. So if we go to our next slide, let's take a look at the square root of -27. So what we're going to do is we're going to break down 27 just as we did before. So I'm going to break that down into 9 and 3, and I'm going to break this down into 3 and 3. So basically, and I'm going to make this negative like a -1 times 3 times 3 times 3. So we know that I can circle groups of 2 because this is a square root. So I'm going to circle a group of 3's there, and I'm going to circle the -1. The group of 3's comes out as a 3. The square root of -1, by definition, is equal to I. And then we have a 3 left underneath. So this is going to become 3i times the square root of 3. So let's talk about 216. Is 216 a perfect square? No. So we're going to take 216 and we're going to factor tree it down. So go ahead and take a minute and factor tree that down. So I chose 6 times 36. You could have done something different. Whatever goes into 216. I'm going to break this down into 2 times 3. I'm going to break this down into 6 times 6, 2 times 3, and 2 times 3. So when I put it under the radical, I'm going to make my negative a -1. And then I've got 1, 2, 3 2's, 1, 2, 3, and then 1, 2, 3 3's, 1, 2, 3. And I'm going to circle groups of 2 because it's a square root. So basically I have a pair of 2's, so that comes out as a 2. A pair of 3's comes out as a 3. We know the square root of -1 comes out as an I. and then we're going to multiply the 2 and the 3 together. So our final answer is going to be 6i times the square root of 6. Okay. So let's talk about how to perform operations with imaginary numbers. So again, you can multiply anything together. So we're going to do numbers times numbers and i's times i's. So negative 5 times 3 is negative 15, and I times I is I squared. But I want you to go back to your definition of imaginary number. We can go further with this problem. We know by definition that I squared is equal to what? I squared is equal to negative 1. Memorize that. I squared is equal to negative 1. So then you can substitute a negative 1 in for the I squared, and then negative 15 times negative 1 is just positive 15. So I want you to understand, you started with imaginary terms, and you ended up with a real number. So that's why we use imaginary, so that we can continue working with our problem. So hopefully, sometimes it works and sometimes it doesn't, but hopefully we can get back to a real answer. So how do we multiply when they're radicals? How do we multiply radicals? Now normally we do outside, outside, inside, inside. But here's what I'm going to tell you. There is one little change that you have to do when working with the negatives under the radicals. You have to deal with those first. So I'm going to have to take out my negative and make this I times the square root of 6. And then I'm going to make this I times the square root of 15. Okay? If you didn't, you would just do negative 6 times negative 15, and the negatives would go away, and you would end up with the square root of 90. And then you wouldn't have the i's. If you check this out, now if we do outside, outside, inside, inside, I times I is I squared. And inside times inside, 6 times 15 would be 90. We can go further, and we can break this apart. First of all, 90 breaks down into 9 times 10 and 3 times 3. Okay, and then this was 2 times 5. So I've got a pair of 3's that can come on the outside, and we know, so I've got a 3 that can come on the outside. We know that I squared is equal to negative 1. And on the inside, I'm going to have the 2 and the 5, which makes 10. So then you can times that together and make it negative 3 times the square root of 10. Again, if you did not take those i's out to begin with, you would have only ended up with just the square root of 90, and then you would have ended up with a positive 3 times square root of 10, and that wouldn't work. You have to work with the i's first. So you have to take the negatives out as an I, and then multiply outside, outside to inside, inside, and then simplify. Okay? How are we going to add? In order to add or subtract, we need to add things that match. So, what matches? 5 matches with 2, so we're going to add those and get 7. Negative 7i and 4i match. They are like terms, so when you add negative 7i and 4i, you will get negative 3i. Can you add those together? 7 minus 3i? No, because the 3 has an I attached to it, and the 7 is just a number in the front. That is a real number, and it is in the correct form, a plus bi. You always write your real number first, so we wrote the 7 first, and then you write your imaginary last. So there's our final answer. Okay, you just add what matches. How do we subtract? We don't subtract. We add the opposite. Say it with me. We don't subtract. We add the opposite. So I'm going to copy, change this to a positive, and then on the very first step, I'm going to give that negative to both of those. So this will become a negative 3, and then this will become a positive 6i. And then it's an addition problem. Go ahead and add those together real quickly for me. So in order to add, we add what matches. So 4 plus negative 3, that is 1. And then negative 8i plus 6i is negative 2i. Can you add those together and keep going? No, because they are not like terms. This is a real number. This is an imaginary number. So you write it just like that in a plus bi form. What kind of problem is this? This is a multiplication problem. And it looks to me like it's a binomial times a binomial. So what are we going to do? We're going to FOIL. So here we go. 6 times 9 is 54. 6 times 2i. And everybody says, Miss Corns, you can't multiply those together. They don't match. You multiply anything together. Okay, you just do your numbers with your numbers and your i's with your i's. So 6 times 2 would be 12, and we're going to just drop the I. Then negative 9i times 9 is negative 81i. And then negative times a positive is a negative. 9 times 2 is 18. And I times I is I squared. My question is, am I finished? So we see things that match. So we can add 12 plus negative 81. And we're going to get 54 minus 69i minus 18i squared. Are we finished? Is there anything else we can do? What do we know? We know that I squared is equal to negative 1. So I'm going to plug in a negative 1, and so that's really going to make 54 minus 69i plus 18. A negative times a negative is a positive. And now our real numbers match. 54 plus 18 is 72. Here's my question. Do we say negative 69i plus 72? So like this, negative 69i plus 72? Or do we say 72 minus 69i? Which one is better? And I'm going to say the second one is, because it is in a plus bi mode. Okay, so that way you have your real number first, 72 minus 69i. So I want you to hit the pause button, and I want you to try this one on your own. So hit the pause button and try this one on your own. Okay, so hopefully you've tried this one on your own. So when I FOIL it together, I'm going to get 49 minus 28i plus 28i minus 16i squared. So we know that the middles cancel, and that makes sense because this looks like a difference of two squares for us. So we know that the outer and the inner are going to cancel. So 49 minus 16i squared. Are we finished? No. We know I squared is equal to negative 1. and that's going to make a positive 16, because negative 16 times negative 1 is positive 16, and then 49 plus 16 is 65. Okay, so let's talk about division. So I want you to think about like what we've already done. And here's what I'm going to tell you. You know, first of all, can you simplify like the 2 and the 6, or can you cancel out the i's? No, you can't, because this is in a binomial. He is protected. This is a monomial. So very similar to the rules that we've been talking about all year long. And everybody says, well, I don't know what we can do. You know, you could try to factor out maybe a 3 from the denominator, but my question is, will the 3 be able to cancel with anything in the numerator? And no, that's not going to work either. So there is another thought here, and I'm going to tell you, you cannot have an imaginary number in the denominator, because technically the definition of an imaginary number is the square root of negative 1. So technically, if there's an I in the denominator, then that means there's a square root in the denominator. And we know we cannot have square roots in the denominator. You can't have imaginaries in the denominator. So what's that word we call when we get square roots or imaginaries out of the denominator? It is called rationalizing. So if we're going to rationalize this, and this is a binomial, what do we need to multiply by? We need to multiply by the conjugate. So tell me, what is the conjugate of 3 plus 6i? 3 minus 6i. And what you do to the bottom, you must do to the top. Okay? So we're going to times this. This is a monomial, so I'm just going to distribute. So 2i times 3 is 6i, and 2i times negative 6i is negative 12i squared. Okay, then I'm going to FOIL the denominator. 3 times 3 is 9. 3 times negative 6i is negative 18i. This will give me positive 18i, which we know is going to cancel. Then 6i times negative 6i is negative 36i squared. Okay, so let's simplify. What can we do? We know this is equal to negative 1, so I'm going to make that a negative 1. So we know that this is going to be 6i plus 12, because negative 12 times negative 1 is a positive 12. Those cancel. We know that this is a negative 1, so this is going to end up being 9 plus 36, because negative 36 times negative 1 is a positive 36. So I'm going to keep simplifying. So first of all, is that written in the right form? Is it in a plus bi mode? No. So let's put it in the right mode. So 12 plus 6i. I'm just going to switch those around so that my real number is first. I'm going to go ahead and add that and get 45. My question is, can I do anything more? And I think you can. And you could take out 6 up top, but my question, does 6 and 45 completely simplify? And it does. It will simplify by 3. It can simplify by 3. So I think what I'm going to do, and I hope this does not confuse you, and we can talk about it more. You can take the 6 if you want to take the 6, and then you can put whatever's left and distribute it back in, and that's fine. I'm just going to take a 3 out, because I know that's what's going to go into 6, 12, and 45. It's 3. So I'm going to take a 3 out of the top, and I'm going to be left with 4 plus 2i over 45. And now that these are on the outside, I can simplify 3 over 45. And that becomes a 1, and that becomes a 15. So my final answer is 4 plus 2i over 15. Okay. Okay, so if we look at example 10, can you simplify, can you cancel out the i's? No. This is in a binomial, and this is a monomial. Okay? So then we need to rationalize it. Now this one's a little different because he's just a monomial on the bottom. You only have to multiply by the conjugate if it's a binomial in the denominator. So I just need to get rid of the I, and I'm going to tell you right now, you don't need to multiply by 5i because that'll just add extra simplifying. Just multiply by I. Multiply by I in the denominator. Okay, so I'm still going to distribute here. So this is going to become 4i plus I squared. And this will become 5i squared. Okay, so let's do some simplifying. We know this is equal to negative 1, so this is going to become 4i plus negative 1 or just minus 1. And we know this is equal to negative 1, and negative 1 times 5 will be negative 5. Okay, and let's make sure we've written it correctly. Is the numerator written correctly? No. So let's put it in a plus bi form, and this will become negative 1 plus 4i. And here's my question is, do you need that negative 1? Yes. When do you have to have a 1, and when do you not need your 1s? You don't need your 1s when you are multiplying or dividing by 1. But when you're adding 1, you best have that 1. Okay, over negative 5. I'm just going to let you leave it like that. You could, if you wanted to get the negative out, you could, I guess, factor a negative out of the top. This is another way to make this, and it'll change all the signs here. It'll make this positive, and then 4i negative, and then this will be, and then you could cancel out these negatives on the outside. So it could become 1 minus 4i over 5. And basically what they do is they change the sign, change the sign, change the sign. That's probably how you would see it written, just because they like for the leading coefficient in that number right there to be positive. So if you had a negative in front right there, or you had a negative in the denominator right there, you knew that you could factor out a negative and then cancel the negatives out. Okay. All right, so the last thing I want to do with you is I want to just talk about the powers of I. And this is going to create a pattern. And if you have this pattern memorized, it'll make it really quickly for you. Okay, so we know anything to the first power, I to the first power is just equal to I. We know that I squared is equal to negative 1. What's another way to write I to the third? You could do I squared times I. And we know I squared is equal to negative 1 times I. So this would be equal, I cubed is equal to negative I. We know I to the fourth could be I squared times I squared, which would be negative 1 times negative 1, which would be positive 1. Okay, so we know I to the first is equal to I. We know I to the second is equal to negative 1. We know I to the third is equal to negative I, and I to the fourth is equal to 1. So every fourth number is going to be equal to 1. Okay, every multiple of 4. So let's look at this. Let's keep going. I to the fifth, we know we can take, what's the highest multiple of 4 that could fit into 5? That would be I to the fourth. And so there would be 1 left over, so that would be equal to I. So again, do you see that the pattern starts to repeat itself? Okay, so I to the sixth could be I to the fourth, because we know anything, basically I'm just going to cancel out anything to the fourth power. Okay, I to the fourth times I squared. And so we know I to the fourth is equal to 1. We know I squared is equal to negative 1, so that's equal to negative 1. So again, the pattern starts to repeat itself. We know I to the 7th is going to be I to the 4th times I cubed, I to the 3rd, or I cubed. I to the 4th is equal to 1. We know I cubed is equal to negative I. So again, it repeats itself. We know I to the 4th, or excuse me, I to the 8th is going to be I to the 4th times I to the 4th, and that's 1 times 1, which is 1. Okay, so it just keeps repeating itself all over. So let me show you a little bit more. So we know this is I, this is negative 1, this is negative I, that's 1. So if we did I to the 9th, what's the highest multiple? Is I to the 8th. And then you have how many left over? You have I left over. So it's equal to I. So again, it repeats. I to the 10th, the highest multiple of 4 would be I to the 8th. And there's 2 left over, I squared, so that's equal to negative 1. I to the 11th is going to be I to the 8th. And there's 3 left over to get to 11. So we know I cubed is equal to negative I. We know I to the 12th is a multiple of 4, so it's equal to 1. So let me see what this does. I think I just want to give you a couple on here. I don't think. Yeah. So let's talk about I to the 33rd. What's the highest multiple of 4? Because any multiple of 4 is going to be equal to 1. So I to the 32nd, and how many is left over? 1, so that's equal to I. What if I had I to the, I don't know, 50th? What's the highest multiple of 4 that goes into 50? And that's going to be 48. How many is left over to get to 50? I squared. And we know I squared is equal to negative 1. Okay. What if I had I to the 23rd? What's the highest multiple of 4 that goes into 23? It would be I to the 20th times I cubed. And we know I cubed is equal to negative I. So if you have those first 4 memorized, if I looked at I to the 72nd, what's the highest multiple of 4 that goes into 72? And 72 is evenly divided by 4, so that's equal to 1. Okay? All right, we're not going to do that, but we are finished, and I have shortened the video a little bit for you.